Hey guys, it's Mrs. Giesbrecht. I wanted to do a couple quick recordings for you on Unit 4 logarithms. So let's first remember what a logarithm is. So if you don't have this in your notes, make sure you guys add it right now. When we are given it in log form, like this, x equals log base b of y, we can rewrite that as y equals b to the x power. So basically what this is saying is when we're given logarithms, sorry, I'm trying to change pen colors here. When we're given logarithms, we can take our base and raise it to the other side of our equal sign. So b to the x is going to equal this y value. So let's try that with the problem up above. Let's take my base and let's raise it to the 5th power. So this is really saying x to the 5th power equals 32. So when I solve that, we know that x would equal 2, because 2 to the 5th power would be 32. So it's very important that we understand the relationship between how we can rewrite our log functions. When you see a logarithm, I just want you to think exponents. That's all that a logarithm really is. So let's try this one. On this one, I just want you to solve log of 100. So a couple things that we need to know when we do these types of problems. The first one is that this time it doesn't show me what the base is. When there's no base here, it's automatically a 10. This is called a common log. So when there's no base shown, it's really a 10. So what this is saying is 10 to the what power equals 100. Because there's no x over there. So again, there's a lot of missing info there that they're expecting us to know is sort of hidden or assumed to be there. So 10 to the what power is 100? That would be a 2. So log of 100 is just a 2. A couple other things that they started teaching you in this unit are when they use the word natural logs. A natural log is when we're going to use a base of e. Now, e is actually an irrational number. It's 2.718, something like that. We're going to use natural logs in very specific cases in pre-calculus and calculus. And the way that we abbreviate that when writing our problem is ln. So ln stands for a natural log. This over here on the right is another way to write the natural log, but as far as our purposes go, you are never going to see it written that way. Instead, anytime we use natural logs, we're going to say ln, and then e would be the base. Common logs, on the other hand, are slightly different. This, again, is when you have a base of 10. So natural logs means e, common logs means has a base of 10. When do we use logarithms? Logarithms are always with exponents. So let's try a couple rules really fast, and then we are going to practice a few of these. So let's take a peek here at what this is saying. There are 3 rules that they are going to teach you in your online lesson about how we can rewrite logarithms. And being able to rewrite them is going to help us solve. Anytime we have an exponent, anytime we have an exponent like the y up here, you are allowed to take that y and put it in front of the log, like they did over here on the right-hand side. So that's rule number 1. Rule number 1, again, to get rid of the exponent, is you are allowed to take the y and put it in front of the log. This is going to come in very handy when we practice a few in just a moment. The other thing that we can do with logarithms is when we have 2 logs with the same base, that's the key, that they are multiplied together, we are allowed to rewrite that, adding them together. So this is going to be something that's going to help us on the next couple slides. Next, when we have a log that has the same base again, that shows division, we're allowed to write division as a subtraction problem. So I want you to think these things through for just a moment. If we were talking before that logarithms are really just exponents, I want you to think about your exponents for a second, and let's see why this really does make sense. Think about this one for a moment. If I say x6 times x2, what do you guys do with your exponents? You really add them. So when I'm multiplying the common base, what do you do to your exponents? You add them. Let's think if that makes sense with logarithms. This would be the middle one right here. When I'm multiplying with a common base of b, look what I'm doing to my logs. I'm adding them. Hey, that's cool. It's the same rule. Let's think if that same rule applies for division. So they both have the same base of x. What's the rule for what I do to my exponents when it's a division problem? I subtract them. So let's see if that makes sense with logs. Check out down here. So down here, when it's a division problem, what am I going to do on the right-hand side? I'm going to subtract my two logs. So logarithms and exponents go hand in hand. I'm going to pause the recording for just a second to put an example on the screen, and then we will go from there. Okay, so let's practice this one. It's going to bring in all three of those logarithm rules into play here. So the first thing we're going to focus on is how to rewrite the top. Now, if the top right now is a multiply, let's think about how I can rewrite that. I can say log a to the 3 plus log of b to the 5. So far, hopefully everybody is okay with that, because we know that multiply is the same as rewriting it by adding. Now I need to take care of that divide by c to the 8. What does divide again mean when we're doing logarithms? It's the same as our exponent rule. So when we're dividing exponents, it's going to be a subtract. So we just used 2 out of the 3 rules. We used when it's a multiply, you change it to an add. When it's a divide, you change it to a subtract. Now there's one last thing I can do to simplify this problem. What was our very first rule that taught us about what I'm allowed to do with my exponent when I have them all logs? What am I allowed to do with it? I'm allowed to move it to the front of my terms. This would be 3 log A plus 5 log B minus 8 log C. So you'll get a lot of practice with this in section 4.4. So I hope that this was helpful, and contact me with any questions. Thanks.